Before we discuss the nuclear reactions in the different types of radioactive particles, let us first have a review on how to get the atomic number and atomic mass. This is helium. The number 4 is the atomic mass, represented by letter A, na pwedeng makuha by simply adding the proton number and neutron number. Meanwhile, the number 2 is the atomic number, which is represented naman by letter Z. Neutral atoms of an element contain an equal number of atomic number, protons, and electrons. Z is always equal to P because the number of protons determines an element's atomic number and distinguishes one element from another. For example, carbon's atomic number is 6 because it has 6 protons. If an atom ay hindi neutral, ang proton number ay hindi equal sa electron number. Kaya when an atom loses an electron, it becomes cation or positively charged atom. And when it gains an electron, it becomes an ion or a negatively charged atom. Okay, let's now go back to the main topic. Nuclear reaction is a change in the identity or characteristics of an atomic nucleus that results when it is bombarded with an energetic particle, as in fission, fusion, or radioactive decay. Nuclear reaction ay nahati into two kinds. Ito ay ang nuclear decay reactions or radioactive decay and nuclear transmutations reactions. But for this lesson, we'll be focusing on nuclear decay reactions. In a nuclear decay reaction, also called radioactive decay, an unstable nucleus gaya ng sa radium-226 emits radiation and it's transformed into the nucleus of one or more other elements tulad ng radon-222. Kaya kung susuriin natin, ang resulting daughter nuclei have a lower mass and are lower in energy. Therefore, it's more stable than the parent nucleus that has undergone radioactive decay, or alpha decay to be specific. Meron tayong 5 common modes of nuclear decay reaction, and this is the general reaction formula. If a radium, for example, ay nag-undergo ng alpha decay, the atomic mass is decreased by 4, kaya from 226 ay naging 222 na lang, while the atomic number naman ay decreased by 2, kaya from 88 ay naging 86 na lang. Tandaan na ang sum of the mass numbers of the products, 222 for radon plus 4 for alpha decay, 826, which is equal to the mass number of the parent nucleus. Similarly, the sum of the atomic numbers of the products, 86 plus 2 equals 88, is also equal to the atomic number of the parent. Thus, the nuclear equation is balanced. Hence, radium-226 after undergoing alpha decay turned into radon-222 with a charge of positive 2. The second type is called beta decay. This is the general reaction for beta decay reaction. Carbon-14 undergoes this type of reaction. Although it does not change the mass number of the nucleus, it does result in an increase of 1 or positive 1 in the atomic number because of the addition of a proton in the daughter nucleus. Di ba nga ang atomic number ay determined by the proton number? If carbon has 6 proton number, 6 din ang atomic number nito. Pero dahil nag-increase by 1 ang proton number, naging 7 na rin ang atomic number. At ano ba ang 7th element in the periodic table? Ito ay ang nitrogen. Hence, carbon-14, after undergoing beta decay, turned into nitrogen-7 with a charge of negative 1. The third type is positron emission, which is the opposite of beta decay kasi ang positron has the same mass as an electron but opposite charge. If beta has a charge of negative 1, positive 1 naman ang charge ng positron emission pero same lang sila ng mass. This is the general reaction formula. For example, carbon-11 undergoes positron emission to form boron-11. And gaya ng sa beta decay, positron emission does not change the mass number of the nucleus. However, the atomic number of the daughter nucleus is lower by 1 than that of the parent. If carbon has 6 proton, ay nababawasan daw ng isa kaya naging 5 na lang. So ano ba ang panglimang element sa periodic table? Okay, it's boron. At kung titingnan natin, the mass number 11 does not change and the sum of the atomic numbers of the products is 6, the same as the atomic number of the parent carbon-11 nuclide. Hence, carbon-11 after undergoing positron emission turned into boron-11 with a charge of +1. The next one is electron capture. If an element gaya ng iron undergoes electron capture, walang nagbabago sa atomic mass nito. Same pa rin, 55 pa rin. Pero ang atomic number is decreased by 1, kaya from 26 naging 25 na lang. E ano ba ang pang 25th na element? Yes, it's manganese. Tandaan na ang X-ray is emitted under EC or electron capture dahil ang second electron moves from an outer shell to take the place of the lower energy electron that was absorbed by the nucleus. Hence, iron 55 after undergoing EC or electron capture turned into manganese 55 with a charge of +1. Last, gamma emission. Here, both atomic number and atomic mass are unchanged, because this is the only kind of radiation that does not necessarily involve the conversion of one element to another. An example of gamma emission is the excitation of the excited thorium-234 nucleus, which is produced from the alpha decay of uranium-238. And since the emission does not affect both the atomic number and atomic mass, hence the same element is produced. Although the emission of gamma rays does not alter the number of protons or neutrons in the nucleus, kaya zero on charge, pero it instead has the effect of moving the nucleus from a higher to a lower energy state, or from unstable to stable state. That ends our discussion. For more lesson updates, please subscribe to my channel.